Namaste students. In this lecture, we are going to derive the expression for the range formula for the condition for the maximum range and maximum height and time of flight for a projectile up an incline without rotating the frame, which you would find in most of the videos where there is a projectile thrown up an incline. What the teachers do, they actually take the incline itself as the x-axis and an axis perpendicular to the incline as the y-axis. Then they split gravity into two components. One would be parallel to the incline, one would be perpendicular to the incline, and then they proceed thereon and so forth. But then that would be easy actually, yes, and less complicated. But for a good exercise of the brain, I am going to use the without rotation method to derive these four expressions. Okay, so let's get started. What we are going to do in this is that we first need to find the trajectory formula for the parabolic path, and we would know that it's an incline which actually would be represented by just a straight line passing through the origin. So first of all, let's define certain uh, specifications here that the angle that the incline makes with the ground, I am going to keep this axis as my x-axis, x cap, and this as my y cap, right, which is the y-axis, and gravity would definitely be downward g constant, right? Now, in this case, the incline makes alpha, and then we have the projectile thrown up uh, with an angle beta with the projectile is thrown with an angle beta with the incline. Now, if I define the entire angle, this entire angle, right, as theta, then I can say that theta is going to be alpha plus beta, right? Just remember that. Okay. Now, let's just take the usual case, right? Since we are not rotating the frame, so if I remove this incline, then it's just usual, right? The same ground to ground projectile and everything remains the same. What happens when I bring in the incline? It simply has a constraint on the entire case, right? Because the particle, once it hits the incline at this particular point, let's call this point L, then it has got certain limitations on the variables, right? We will discuss that one by one. Let's first see what happens when the particle reaches this point L. In this case, what will happen is that if I draw a perpendicular here, if I drop a perpendicular from L to the x-axis, let's say, and let me call this perpendicular as LM, that's going to be my y coordinate, yes or no? And then from origin O to M, this is going to be my x coordinate. So the range here, I can say that the range is going to be the length of O to L, and that is simply square root of x squared plus y squared. Is it not? Now, since the incline itself is a straight line passing through the origin, its equation can simply be given by y is x tan alpha, right? Because alpha is the angle that the incline makes with the x-axis. Basically, it looks like a straight line passing through the origin with an angle of inclination to x-axis as alpha. Y is mx plus c is 0, m is tan alpha, so y is x tan alpha, right? So if I put that value here, then the range is simply going to be square root of x squared plus x squared tan squared alpha, that I can simplify as x square root of 1 plus tan square alpha, and that would be x sec alpha. Square root of 1 plus tan square alpha is sec squared alpha, and square root of that is, square root of 1 plus tan square alpha will be square root of sec squared alpha, and that is x sec alpha, or that is simply x upon cosine alpha, cos alpha, right? So let me first note this thing. The range will be x by cos alpha. For now, let's be happy with this. But now, what will be the x? What exactly is x? X is the x coordinate. So basically, as long as the particle is away from the incline, it could have any coordinate x and y on the parabola. However, when it reaches L, that means whatever its x and y coordinates are, right, those coordinates will satisfy the trajectory equation as well as of the straight line, right? It will be the solution to both the equations. So first of all, let's find the trajectory equations for the parabola. Trajectory, right? So how would you find for the trajectory for just a normal parabola ground to ground projectile? It's the y coordinate is simply given by the formula which we have already studied in kinematics, as is ut plus half at squared, right? Instead of s, it's the vertical plane, so vertical direction. So y is ut. What is u? Okay, first of all, let's see. This is the initial velocity with which it is thrown at an angle theta. That means the horizontal component is u cosine theta, which remains constant throughout. And then the vertical component is u sine theta, as usual, as we have already used these expressions for ground to ground projectile. So it's going to be u sine theta into t minus half g t squared, right? Because acceleration here is negative g. But this t needs to be replaced. How? We know that at any given point, the x coordinate will be simply u cosine theta, which is the horizontal velocity multiplied by t, because the horizontal velocity remains constant in the absence of air resistance. That's the case. So from here, I can simply find t is equal to x upon u cosine theta, right? So plug that value of t here. That means I can simply say y will be u sine theta into x divided by u cosine theta minus half g into x squared divided by u squared cosine squared theta, right? Let's simplify that. So y is going to be u and u cancels. So it's x tan theta minus gx squared divided by 2u squared cos squared theta. That's my y, which is the same trajectory equation that we used for the ground to ground projectile. However, I can simply replace the y's value because for an incline, the y will always be x tan alpha, right? Especially when the straight line makes an angle alpha with the x-axis, right? So here I will put x tan alpha will be x tan theta minus gx squared divided by 2u squared cos squared theta, right? So what we're gonna do? Gx squared, if I take it to the right left hand side, I gonna it's minus gx squared by 2u squared cos squared theta taken to the left hand side becomes gx squared by 2u squared cos squared theta. On the right hand side, x tan theta, then minus x. This comes to the right, x tan alpha, which is nothing but x into tan theta minus tan alpha, right? So see, since if we go back to the diagram, you will see at this point, right? Of course, x is not 0, right? So we can cancel x from both sides, right? We can cancel x from both sides, and we will have x will be 2u squared cos squared theta, the entire thing divided by g, yes, and then tan theta minus tan alpha, yes. But we can actually simplify tan theta minus tan alpha. How? We know that tan of theta minus alpha will be tan theta minus tan alpha divided by 1 plus tan theta tan alpha. So we can write tan theta minus tan alpha will be equal to tan theta minus alpha multiplied by 1 plus tan theta tan alpha, right? That means I can simplify tan theta minus tan alpha will be equal to tan of theta minus alpha. We know theta equals to alpha plus beta. So theta minus alpha is equal to beta. So it's going to be tan beta. But again, this entire thing 1 plus tan. So I can simply write it as 1 plus sine theta sine alpha. No, sorry, sine alpha divided by cos theta cos alpha. Right? The entire thing can be written like this. So tan theta minus tan alpha will be equal to tan beta. Let me go to the left and write it in one single line. So this is tan beta. Into this thing will be simply what? Cos theta cos alpha plus sine theta sine alpha entirely divided by cos theta cos alpha. So again, this is tan beta. This expression looks like cosine of theta minus alpha entirely divided by this cos theta cos alpha. So now I have tan beta, and again cos theta minus alpha is cos beta divided by cos theta cos alpha. That means my tan theta minus tan alpha is equal to tan beta cos beta will be simply sine beta divided by cos theta cos alpha, right? So I can simply replace my tan theta minus tan alpha to sine beta divided by cos theta cos alpha. So I can write that x is equal to 2u squared cos squared theta by g into sine beta divided by cos theta cos alpha. Cos theta cos alpha. So here cos theta would take 1 power of cos squared theta in the numerator. Now simply speaking, x is 2u squared sine beta cos theta divided by g cos alpha. We will be needing this value of x much later, but for now that is the value of x. But since we already have the value of x, can we not find the value of L, which we range? We have found the range is x by cos alpha, right? So range from here, we can say that range is going to be x by cos alpha. So it's going to be 2u squared sine beta. Now instead of writing cos of theta, I will write it as alpha plus beta, right? Divided by g cos alpha, but we are dividing x with cos alpha, so it becomes cos squared alpha. So this is the expression for the range. Okay, so we have finished the range formula. One has been finished. So one. Now, condition for the maximum range. When would the range be maximum in this case? So for the maximum range, right, for R to be R max, we need to know that dr by d beta should be 0 for the maxima, right? So let's, since all of this for range, For range which is 2u squared, for range which is 2u squared sine beta cos of alpha plus beta, divide that with g cos square alpha, the rest everything is constant. Oh, sorry. This entire thing is constant, isn't not? What is variable? Sine beta cos alpha plus beta, right? So I can simply write, what I can write is that d upon d beta of sine beta cosine of alpha plus beta must be 0. That means it's a it's a product rule of differentiation, right? So sine beta's derivative will be cos beta, then simply multiply cos of alpha plus beta, right? But then we go to the right a little bit, multiplied by sorry plus, then sine beta as it is, cos alpha plus beta will be minus of sine alpha plus beta, right? Then alpha plus beta would have a derivative equal to 1, and that must be 0. This must be 0. That means it's going to be cosine beta plus cosine beta into cosine alpha plus beta minus sine beta into sine alpha plus beta will be 0, which is exactly the expanded form of cosine a plus b. So here cosine, here a is beta and b is alpha plus beta. So just add them. It's going to be alpha plus 2 beta. Right? That will be 0. If that is the case, then alpha plus 2 beta must be equal to 90 degrees or pi by 2, whatever you choose. Then beta would be 90 degrees minus alpha by 2, or you can say beta is equal to 45 degrees minus alpha by 2. So condition for maximum range part 2 is done. So part 2, max range is when beta is equal to 45 degrees minus alpha by 2. That's, yes, part 2 is done. Next, we are going to basically, how can you now, it is, I leave it up to you. Let me know what answer you're getting in the comment. Find the maximum, so maximum range. So what you need to do is to simply put in the value of beta as given in this expression into the range formula, right, which is here, right, into the range. Just instead of beta, put in the value that we have obtained for the in the condition of maximum range, and you will find the R max. I leave it up to you as exercise. Now then, how would you find the maximum height? Well, for maximum height, we need to understand one thing. Let me just copy this image and tell you something here. It is a little difficult here to find the maximum range because it's like this is where actually by rotating the frame, you will clearly see that it will be much easier for you to find the maximum, maximum height, right? But since we are not rotating the frame, let's do the hard work, right? Okay, when do you think the range is maximum? The maximum height above the incline, right? The maximum height above the incline would be somewhere here, let's say, right? Let's say that is where the distance or the displacement of the projectile with respect to the incline is the maximum, right? So let's call this point as point P. This point as point P, and basically P, if I take this particular line as a normal, Let me call this one as my Q. Yes. Now from Q, if I drop a normal again, this is 90 degrees. If I drop a normal again, normal M, in the previous case I also had a normal. What did I name? M. So let's not use the same, although we can use it. But I just want to keep points strictly differently named. If I drop a normal on the x-axis like this and name this point, this is PQ. Let's call this point as N, right? So what we are getting here, right? Let's suppose PN intersects the incline at a point. Let's call this point as S, right? And this point is origin O, right? With all of that, this is the maximum height. PQ is the H. This PQ part is a maximum height H. How would I find? If I could somehow find PS, right? If I could somehow find PS, then I can take the for the triangle PSQ. PS is the hypotenuse, and the maximum height is the perpendicular, right? And then I can use the trigonometric identities, right? So first of all, let's understand this angle is alpha. This angle is 90 degrees. So this angle is 90 degrees minus alpha. So this angle is also 90 degrees minus alpha. So H, I can write H maximum height is PS sine 90 degrees minus alpha, right? For this angle, which is the base angle. Or I can simply write H is PS cosine of alpha, right? So if somehow I can find PS, I will be able to find H, maximum height. But what is PS? It's simply the difference, as you can see, difference in the Y coordinates, right? Y coordinates, it's simply the difference in the Y coordinates of what? Of the projectile and the corresponding point on the incline. Yes? Right. So this point is the see both P and S have the same x coordinate, right? The same x coordinate x, but for the same x, the incline gives me a value yi and the parabola gives me a value yp. So basically for the same x, one point will have the point P will give me yp, that's the y coordinate on the parabola, but S will give me the y coordinate on the incline. So if I could somehow do yp minus yi, then I will have my PS. And then once I have my PS, I will have my H. So how would you find that value? See, how would you know where the point P will be? See, wherever the point P will be, it will basically have a velocity such that the velocity here will be parallel to the incline. That's where it will have the maximum height, right? If it has any component, right? If up till this point the velocity will have some angle, some vertical component with respect to the incline, right? And this is going to take it even higher. So only when this component becomes zero, which is where at P it will happen, then you will know that then the particle or the projectile is no more going to rise further with respect to the incline, right? So the velocity at P has to be totally parallel to the incline, correct? But the velocity is also the tangent, right? The velocity vector is always given as a tangent to the incline, yes or no? The velocity vector is always a tangent to the incline, correct? So the slope of the tangent at P will be the same as the slope of the incline, right? That means in the trajectory equation, if we can find the slope, which is dy upon dx for the projectile equation, right? Then we will have that as the slope of the incline, which is tan alpha. That means let's do it. So first of all, we rewrite y will be x tan theta for the projectile, the parabolic path, minus gx squared by, where was the equation that we derived? Yeah, here it is. X tan theta minus gx squared by 2u squared cos squared theta. 2u squared cos squared theta. So let's find dy by dx. That would be tan theta minus 2gx divided by 2u squared cos squared theta. And 2 and 2 cancels. And that becomes tan alpha, right? That means we can write that gx upon 2u squared. Oh, sorry. Why would there be a 2? So it's going to be u squared cos squared theta will be equal to tan theta minus tan alpha, right? So basically, I'm focusing on this part in this particular step. And what I did, I take the minus thing, like to the right hand side, and then tan alpha to the left hand side, and then finally flipped it left to right. Okay, so that's what I got. So from here we can find x, right? And we know already tan theta minus tan alpha. So let's just simplify that. What is tan theta minus tan alpha? The expression, the beautiful simplified expression that we had gotten, tan theta minus tan alpha is simply sine beta into cos theta minus cos alpha. So can we just simply copy it? Let's copy that, right? Which is equal to, so, right? Now x will be u squared cos squared theta divided by g into sine beta divided by cos theta cos alpha. Okay, so looks like it. Cos theta, cos theta. Okay, cos theta will cancel one part of cos squared theta. Now we are ready. Let's u squared sine beta cos theta, divide that with g cos alpha. Right? That's the value of x. Right? If I again copy it from here, so I can simply write that means my x is equal to, right? So I have this simplified x. That is the value of x in the diagram where, let's go back to the diagram. This is the value of x that we have gotten, right? So from that value of x, we can find yi and we can find yp. So how would you find yp? First of all, let's find yp. So yp will be the projectile equation where the value of x is this, right? So it is again going to be x tan theta. So it's going to be u squared sine beta cos theta tan theta divided by g cos alpha minus, again, the projectile equation, refer back to that, gx squared or gx squared divided by 2u squared cos squared theta. Gx squared divided by 2u squared cos squared theta. Let us simply uh, copy that from here, right? If I can copy it. Right. So in this expression, instead of x squared, I will simply write, I'll take this x squared out. I will write x squared. Instead of x squared, I will simply put it here. This entire part, x squared is u fourth sine squared beta cos squared theta divided by g squared cos squared alpha. Now let's do a lot of simplifications to this. So it's u squared sine beta cos theta tan theta, it's simply sine theta, isn't it? That is cos theta, but then sine tan theta is sine theta, right? Let's write that, right? Divide that with g cos alpha as it is minus. So inside the bracket, a lot of things are going to change. G will cancel one part of g there. So u squared will cancel two powers here. Cos squared theta would totally be cancelled. So what I have now is u squared sine squared beta, right? U squared sine squared beta divided by 2 g cos squared alpha, right? So I think I should be multiplying 2 and 2, right? So that again square it and have cos alpha multiplied there. So that now I can take 2g cos squared alpha as my denominator, common denominator. So yp will be equal to 2g cos squared alpha. Here I'll have 2u squared sine beta sine theta cos alpha minus u squared sine squared beta, right? So if what we're going to do, we are simply going to shorten it. We will write u squared sine beta divided by 2g cos squared alpha as common, and then I will have what I have is u squared sine squared beta, u squared is taken common. I have 2 sine theta cos alpha minus sine beta, right? Now it is u squared sine beta divided by 2g cos squared alpha, and then 2 sine theta cos alpha would simply become sine theta plus alpha plus sine theta minus alpha minus sine beta. So instead of writing one more step, I will simplify it because sine theta minus alpha itself is sine beta, and sine beta cancel. So I have my yp is equal to u squared sine beta sine theta plus alpha divided by 2g cos squared alpha. Right? So I have yp. I need yi. Right? I just need y on the incline for the same value of x, which is just x tan alpha. Right? That's x tan alpha. But x value, the value of x is already obtained here. Right? For the incline, y will always be x tan alpha, right? So I will simply write it as this into tan alpha. And that would simplify things as u squared sine beta cos theta sine alpha tan alpha. I'm simply decomposing into sine alpha by cos alpha. So it's going to be g cos squared alpha. You see? Yi has already been obtained. So if I do my yp minus yi, I will be getting this part, right? Ps, which is this point if I write it in red, so from P to S, this part if I get, then I can simply multiply cos alpha with that and find my maximum height edge. So let's proceed. PS will be YP minus YI. So PS will be YP on the parabola minus Y on the incline. And that is, just write down this expression like this minus this expression right here. Yes, minus this. Okay, so this now becomes, see, I can just have 2 and 2 multiplied here. So I will have u squared sine beta divided by 2g cos squared alpha taken as common. So inside the bracket, I will have sine theta plus alpha minus, I've taken u squared sine beta as common. That means I'm left with 2 cos theta sine alpha. Yes, that's it. In the next step, all that I need to do is to use PS is equal to the same PS here will be u squared sine beta divided by 2g cos squared alpha. But sine theta plus alpha is sine theta cos alpha minus, sorry, plus cos theta sine alpha. But then I also have minus 2 cos theta sine alpha. So this would result in a very easy deduction. So basically, cos theta sine alpha minus 2 cos theta sine alpha is simply minus cos theta sine alpha. So now this resembles a very simple formula. Sine theta cos alpha minus cos theta sine alpha is simply sine theta minus alpha. Right, that is simply sine theta minus alpha. But theta minus alpha is beta, so I will write it as simply sine beta. But sine beta into sine beta is again sine squared beta. That's my PS. Then for the maximum height, all I need to do is to get PS and multiplied with cos alpha. And that is u squared sine squared beta divided by 2g cos squared alpha into cos alpha. So basically this would cancel one thing here. So I will simply have my maximum height is u squared sine squared beta divided by 2g cos alpha. I think that would be the third thing that we set to find. Yes, let's go back to the top and see what was on our agenda. Yeah, max height. We have found max height. We found range formula, condition for maximum range, maximum height. Time of flight is the one that is remaining, which is pretty easy to find actually. This is 3. Now, for the time of flight, what we can do, we know that the x coordinate along the incline, we already know what the x coordinate is going to be. Yes. So x coordinate on the incline is this u squared sine beta cos theta by g cos alpha, right? Right. But let's understand one thing from this diagram. See, the time of flight is when let me explain that what I mean by the time of flight by repeating the same image here. Look at this image again, right? What is the time of flight? The particle starts from this point O. It takes this path. goes on like this, and eventually reaches L, and then it stops moving, right? So from 0 to the point L, it might be moving in a parabola, but once it reaches L, then all of its motion ceases, right? That means if this is my N, or M rather, because that's the point I had taken as M. So once it reaches L, so starting from t equals to 0, when it reaches L, then the time would be the time of flight, right? So when that happens, the particle's x coordinate is simply OM. And all throughout, it has not changed its the x component. This is u, right? The velocity, initial velocity u, and this angle is theta. Then u cos theta has remained a constant all throughout for the entire time capital T, right? That means x can easily be given by u cos theta into time of flight. So I can find my time of flight as whatever is the x coordinate when the particle hits L divided by u cosine theta, right? U cosine theta. So just write this, no? This expression, that is, I have to simply multiply 1 by u cos theta. So 1u cancels and takes a power of u in the numerator, and the cos theta simply cancels this. So my time of flight is going to be simply u sine beta divided by g cos alpha. And that's when I can say that I have completed my agenda, right? So if you have any doubts in the entire process, if you find out any mistake, let me know in the comment, right? So see you in the next lecture where I will easily derive from these four expressions, right? From these four expressions, I will derive the expressions for the down the incline projectile, which trust me is going to be much shorter, right? It we can simply find from here. So let's summarize all these equations at one place so that you can take a note of this. So my one is the range. So let me find out the summary is here. Summary one is the range. Summary for projectile up the incline, right? But just in case you need a reference, this is the horizontal x, this is your y cap, x cap. The incline is at an angle alpha. The projectile is thrown with a velocity u at an angle beta with the incline. That's it, right? So in this case, the second point would be my condition for maximum range. Second point will be where I had obtained the condition for the maximum range. Yeah. And then third point is the max height, which is h. And the fourth is the time of flight. Just this beautiful and elegant equation. Yes. So let me zoom out so you can take a screenshot or something. Okay, so see you all in the next with all this expressions which we had already found for the up the incline projectile. In the next lecture, which will be much shorter, we will just convert these or transform these four into a projectile down the incline. Till then, see you. Bye bye.